Ben. We built it as a SaaS up through about July, and then we switched into AI native in September. And then we've been on that track ever since. We rebuilt it from the ground up, but we leveraged a lot out of what we had built over the last year. Okay, great. All right, everybody. I think we can go ahead and get started. Thank you so much for being here. If you haven't already noticed, it seems like everybody has pizza, drinks, everything at the counter. Enjoy yourselves. Kick back, relax, act as if you're at home, but keep your shoes on, okay? For the most part, at home. My name is Justin, the founder of a company called Infracodebase. Tell you more about that in just a minute. On the phone here, we have Tarak, my co-founder from France. Say hi, Tarak.
Hello, everyone.
And
Can you hear me?
yeah, we can hear you. Yeah. And then over here we have Ted Prendergast. He's our head of enterprise sales. I myself and Ted both used to work here at Slalom, so it actually feels really great for us to be back in the room, see some friendly faces, and some. Actually, I think I've seen everybody in this room at one point or another, and things that we've done in the past. The goal today is to really talk a little bit about the future, and to show a little bit of what some of the future is going to look like. And we'll start by kind of talking about some problems that people are going through right now. So historically, I'd say think about the typical enterprise. They have a process where the business has great ideas. They're the closest to their customers and they know exactly what they need to generate value for their company. And so they get these great ideas from their customers and like, we want to build something. And most large enterprise companies have a pretty large cloud environment. They have requirements to secure infrastructure and host applications internally, whether on-prem or in the cloud, to be able to deliver those services to their customers. But then it all breaks down when they go to the cloud. So they got the money, they got the motivation, they've got the team, they know what they want to solve for, and then they ship that request off to the cloud team, and it's nothing but silos and bottlenecks, and wait a little bit longer, and we're just about there until 6 months later you realize, shit, we're just now going to start building our application, right? A typical life cycle might look like you go into a line on what it is that you're actually doing. You do some design work, and all this is kind of happening synchronously, right? You're doing some functional, non-functional requirements gathering. You're kind of confirming security requirements with your security teams. And then ultimately you're packaging this up into a thing that you're going to hand over to somebody else who wasn't even involved in this process, which is your platform engineering team, the guys who are going to, and girls who are going to write the infrastructure code to ship this to your cloud environment, or maybe go into the console and click around and create whatever it is that they're supposed to create. There's a lot of breakdowns and friction in that process. If you're doing this as code, all along the deployment process, you're likely to hit CI bottlenecks and issues with deployment and all these different types of things. And then if you're ClickOps, of course, you have the problems of nothing is repeatable. Every environment could look a little bit different. Why is it working in dev, but it's not working in prod? You see a lot of that kind of stuff still as well. And so one of the things that our product aims to do is to help to solve a lot of that. I'm going to talk a little bit about how it does that. There's another kind of cohort as well, consulting, which has big problems as well. AI has totally changed the landscape for client expectations for consulting companies. Their expectation to deliver faster, better. The sentiment is in the enterprise and in consulting that AI has been here for years. Why aren't we moving faster? Why aren't we moving cheaper? Why aren't we more nimble than we were before we had all of these amazing tools, right? The reality and the facts of things are that most CTOs are not seeing a lot of benefits from AI at the scale of their organization. There's pockets of expertise and people that are doing great things, but AI, just like it can scale some of your best mind share, it can also be a way to accelerate a lot of really bad practices and really bad habits and things like people not really paying attention to what's going on, just kind of trusting AI to solve the problem. So just to re-highlight some of the things that I mentioned here, over 3 months to deliver, Gartner, 33% of AI output is not trusted. This is one that I haven't talked about, but you have the desire for speed, but also we've seen from 2025 to 2026 that trust in AI has dropped from 42 to 33%. And then something that we know from Gartner studies and IBM is that almost all security issues are through misconfiguration and could be avoided had they been addressed up front. And once they get into production, they're 95x, more expensive to fix. And so we really want to avoid this. We want to improve the speed of delivery. We want to improve the trust in the output. We want to ensure that there is no possibility of misconfiguration when things get shipped so that you never have to deal with this reality of really expensive things that you have to try to fix later. Any questions about kind of the general problem statement? And then I'll tell you a little bit more about the product as well. and we'll do some practical examples today. Oh, we've got some users in the house. Okay, good. No. Okay, we got a super user over here. Derek, tell us all the things that you've been building on Infracodebase. We really have to know. When did you try it? July. Ooh, oh, you got to jump back in July. This is not even, you'll see, not even the same. In fact, your account may not even transfer. I would, what it really is. And, so I don't want to be too generic about this because it's easy to water it down. But really what we're doing here is we had the SaaS product that we had built. When we introduced a little bit of AI, people were like, okay, I'm using that. And for the things that didn't work for, they said, can you give me more? So we said, clearly, the way that people want to interact with this product is through agentic development. And so ripped down the entire application, stripped out the best parts of the product and all the learnings that we had over the first 6-7 months of development, and then reincorporated those into an entirely new AI native application that aims to solve the problem that we talked about previously. When I say AI native, what does that mean? It means that the primary way that this product works is using agents. So it's like an agent platform with guardrails so that you can protect the value of the non-determinism of agents without making it so that they're unpredictable and can't solve the problems that you need them to solve. So that's what it is. The agentic platform for cloud infrastructure helps you to design, code, ship, and operate infrastructure. And I think we'll see a little bit of all of that, maybe a little bit less of operations, but definitely the first three. I'll go ahead and sign in. I don't know how techie or nerdy everybody is, but what's actually kind of interesting about architecturally the product, initially when this was built, I've gone through a lot of evolutions as a product leader and as a technology leader, and I've gone through a lot of different swings in my philosophies about how things should be. These days, I'm in sort of a modular monolith kind of mindset, where you can over-optimize early, have too many microservices, and really make things a lot harder for you to ship fast. And so originally, this had a Go API, several of them, Python APIs, and TypeScript APIs. And it had Bun for the front end runtime. It was using Remix, which was built by, I think, Shopify or Spotify or something, for what they do. Great, individually great tools. When you start to string all of these different things together, you start to realize the complexity and where things start to really break down. So when we rebuilt, we actually built a modular monolith. Everything's in a single repository. Everything is TypeScript, and it really reduces the cognitive load, but also from an engineering perspective, it means we have one way to kind of inform our agents on how to scale us in building the product. So that's what enables us to use AI every day to create 5-7 PRs and ship things every single night to production without breaking a single thing for a single user in a product. It's been a pretty interesting journey to kind of go through and see that. So when you land in the product, sorry, any questions about that? I don't want to run through it. If you guys have questions, come on, you can walk up. You can walk up to me. I can talk to you right here. This is the talking space. If you want to talk, just raise your hand. Happy to come over. Okay. Trying to keep it fun. I don't want y'all falling asleep on me. So here's where you land when you get into the product. A couple things about the product, technically how it works, is you have an enterprise. The enterprise is where your billing sits, as well as your guardrails and configurations for the agentic platform layer. That's where you can configure your own agents, build your own agents. It's where you can add your MCP tooling to connect to your cloud ecosystems and Notion, Confluence, Jira, whatever it is that you're using for project management, documentation storage, etc. It's where you can build workflows. We don't do workflows don't think N8N, like very modular AI workflow steps. Think semantic router for agents. So a visual designer, and you'll see it, with natural language for guiding agent behavior so that you don't go from have an agent that just wants to execute constantly. And then the last thing is the other thing I'm talking about. All right, so I'll pull that up here. You can see it. So we have sub-agents in here. You can build customized individual agents, policy, governance architects, OWASP, threat modeling. Whatever this is, you can build a team, and then the agent can orchestrate these. These are rule sets. At the enterprise level, think about this as the way that you publish standards out to your entire company. So you can say, our standard as a company is this for Azure Key Vault security. and we're going to make it available to you. We're not going to require it because not everything's going to use Key Vault, but if you use Key Vault, turn this on, and then you're going to be automatically complying with our security requirements. So that's what this enabled is publish it. The required column is like you have to use it when you create a workspace, and we'll talk about workspaces next. So right now, the only thing we're requiring is our Terraform guidelines for coding. This is tools. So you can see here, we just have a bunch of different tools connected. MCP is the integration layer for agents. To the extent that we can, we leverage what the official providers are publishing from their own GitHubs and pulling those in. One thing to note, interesting technically on this, is that and I don't know if this is normal or not normal because the patterns around MCP dev and platforms like this is still kind of emerging. We don't have like persistent servers that host each one of these because we don't want any client's data touching any other client's data, all through the same service and the same compute layer. So what we actually do is we sandbox every single session where it instantiates its own stdio instance of that server in the platform, so that it can run totally privately for that workspace, for that session, for that user. Kind of cool. And because of the way that these are built, what's really nice also is that just the same way you can add a little JSON snippet inside of your cursor or whatever, we can do the same thing here to bring new MCP tools to market. Simply add a snippet of code and make sure that the dependencies in the Docker container are appropriate. And I'm just trying to I can tell we got some tech people here, so I'm letting myself be a little bit more technical because maybe that's more interesting. Yeah, this is workflows, which I talked about. Workflows, again, this is just a semantic router for agents, and it is a natural language way of describing what you want to do in what kind of order. It's got some very simple things, a start and an end node, instructions, and decisions. And so you can come into a decision, for example, you can add other decision nodes, and then you can come in and connect this to, some other thing, and then you could do whatever, right? So that's that. And let's go back one more to the settings. And we have secrets. Secrets are just a way to inject environment variables into your workspace so that your agent can do stuff just like you would on your local machine, but inside of its little sandbox. All right. Any questions about enterprise? Maybe one more thing that's interesting is integrations. So here you can connect to GitHub. We use GitHub apps for connecting to your GitHub environment. It can be personal or it can be your organization's GitHub. The agent comes pre-configured with some pretty common tools, right? All the major IAC language CLIs, as well as the cloud provider CLIs, Helm, Kubernetes, and Ansible for configuration management. This is going to be changing very soon. Pretty soon, this is going to give you granular control for the agent at every single thing like bash, or I'm doing a read, or I'm doing a write. So at the enterprise, you can turn certain features off, and you can also add like deny or require approval or auto approve kind of settings from this page. So that's in a feature branch right now. And then of course you can measure the usage of the tokens that you use in the product. You have workspaces and you have users, and we're also going to add teams to the metrics here. In terms of managing people, you just invite people. All your friends is really the way I say it. Is like any email you have, I would put it in this box. So this box here is just basically think of it like put any email, every email that you have in your every one of them, and just hit the button, and then it works. And then you can create teams. So pretty standard RBAC stuff, right? Okay, we have a security team, we have a DevOps team, we have an X team. You might give them different permissions to do different things inside of the product. Also, this helps with workspace management clearly because you could, like, instead of adding Jeff to every single workspace, you just add the team that Jeff is on to every single workspace. Okay. Clear as mud. Now we've got workspaces. Workspaces are where the work happens. I'm going to do some ASMR to keep you all excited. You can create groups. So this is maybe an us problem, but we have like a lot of workspaces. So recently created groups so you can start to organize these things. I could put this here. I could say this is, Carl's, whatever. It doesn't matter who it is or what it is. It could be anything. And then you can move stuff to those groups. So you can start to organize, collapse, and just kind of make this easier to work with. I'll remove that, so it doesn't show up in a customer demo. And inside of here, we have, inside of a workspace, you can see the diagram that's been created. You can see about a description about this thing, the languages that are used, the collaborators, the code, very similar to GitHub. The way that we think about this is that we're really trying to create the community for architects. Like right now, GitHub is great, but it's not necessarily the place you think as an architect to go to connect with other people that are building things and designing things and sharing ideas. So we want to be the hub for that community. And as a part of that, you can also have public profiles, just like GitHub. So here, you can see all the different types of projects that I've been working on as long as they're public, right? So AWS Knowledge Graph, Finos, Infracodebase Infra, which is we're using our product to manage our infrastructure. Break it, what Azure, Foundation, whatever. The cool thing about it is, from a public profile perspective, is people can immediately see what languages you're kind of working on, what kind of clouds you're working on. So when you say you're multi-cloud, you can say, yeah, multi-cloud, and I can prove it. You can come here, you can see all my projects, you can look at my portfolio of work. So this is a really exciting feature, which leads into kind of another piece of this, which is that we have something called templates. Templates are similar to, think of it like GitHub, like public GitHub repositories. Anybody that creates something that they're publishing publicly can be consumed from this and then forked for whatever you want to do. So there might be a creator here that's, oh, that's interesting, like a fintech app. I wonder what that looks like. Oh, that's pretty cool. They built something neat. That's maybe I should take a closer look at like the things that they're building, and I can come and take a look at whatever they're doing, right? Okay, so enough of that. But really, I think what's important here, and I'll speak as a founder and less as like a technology person, is that we really believe in having like a really small group of very highly functioning and smart people who have a big heart in this and like want to solve these problems. And so I think for us, it's we're trying to figure out things that scale, that don't necessarily scale with capital or scale with headcount. And one of the things that you can do there is around building an amazing community and actually providing value to that community. So we view a lot of that as like a flywheel for like bringing people into the ecosystem and learning from them and building alongside them. Oh. Yeah, Carlton had a question. What was that, Carlton? Sorry, no, I couldn't hear you there.
What was this app originally called?
So yeah, what was it called? I've been through a lot of iterations of things since probably 2020, to be honest. Like I built a Python library that was a design library that did things like this. You would say, like my thing was, I don't think that architecture should be something that lives in some other version control system. It should be in code. So I built those things way back when, and I would say this is like more than half a decade of just experimentation with what works and talking to people and finding real problems and trying to solve things. So 10 different things, I probably would call them, all coming together into like one massive thing. All right, let's get down to brass tacks here and build something together. I'll go into the workspaces. So the way that you get started with the product, you come in and you create a new workspace. So again, you can start from templates, you can start from scratch, or you can start from an existing GitHub repository. So this is really important because most of the companies we talk to, they're not starting a fresh project. They've got a lot of infrastructure already. Either it's been ClickOps or it's inside of a GitHub repository, and they need a way to bring that in to make sure it's secure, that it meets their standards, that it follows best practices. So whether we're kind of just basically saying, we're meeting you where you are. If you have code today, we'll work with code you have. If you don't have code today, then you can start fresh. Of course, you can see here, you can pick whatever repos are connected in your integrations inside of the enterprise. Here, I'm just going to add one. This is going to be our, so this is our Slalom demo, create a workspace. And since I guess this is an AWS Meetup, although I don't know that you guys mind, we'll build something on AWS. So I did kind of come out here and look. So first of all, here's my AWS environment. It's pristine. There's nothing in here. I keep it clean. And then this is the MCP server use case that I found in some official architecture documentation from AWS. Here are some security best practices for S3 buckets and a pitch deck. Okay. So what I'm going to do is I'm going to try to create this thing. So if we look at what it is, it's an MCP server use case that enables deployment and management of model context protocol servers on Amazon Bedrock Agent Core. MCP servers, I'm sure everybody knows, but we talked about it before, are the kind of the integration layer for agents. They're the things that give the agent agency, lets it take action and do things inside of other API-based systems. And even just execute business logic and things like that. So the way I'm going to do this today is I'm going to take a picture of this. And I'll also copy, I don't even know that I need to, but I'll copy some of this text. So this is one way to do it. You could imagine, like, if you were at a company, you would have non-functional, functional requirements, security requirements, whatever. Something else I'm going to do before we get started as well is kind of reiterate one of the features that we talked about with the product, which is rule sets. So here you can see all of the things that are published at the enterprise and this one required rule set that I personally can't modify. But what I want to do now is actually import a new rule set. You can point to a public URL and say, I'm going to use whatever that cloud provider is publishing as a best practice. That's the way I want to start. Or you could upload something that is yours exclusively that you've designed. This is the AWS well-architected framework. So here you can extract rules. You can also add custom instructions to this to say, like, don't extract any of the rules about this, or when you write rules, do it in this format, whatever you want to do. And then this is how you get things into the product. So one thing that we've heard from a lot of people is we don't want to create these from scratch. We've already been through this effort. We've already got them documented. They already exist on the web. So this is sort of a nod at that. This will take just 1 second because it's a pretty large document. But I want to show you what this looks like when it's done. "14 megabytes. I think it's like 80 pages or something." Yeah. I know I really should pick a smaller document for demos. The small ones are like, but big is better. Yeah, exactly. So the goal behind rule sets is take the best knowledge of your company, put it into one place, and that way you can truly do intent-driven infrastructure. One of the reasons intent-driven infrastructure doesn't work is because agents don't have enough information to meet your requirement, the intent. When you embed your rules into the platform, then you can start to say stuff like build a web app over SQL. You start to get to that point where the app developer could almost come to your cloud team or like to this tool and do this, because by default, they're going to get your security standards and best practices and everything else. So we're really trying to abstract a lot of that knowledge that's locked into these specific people, put it into a place where everybody can take advantage of it and that we can all work together a little bit better. So you can see what it did, right? It took a bunch of rules out, improved through game days, organized teams, business outcomes, whatever. So it brings all these rules in. I'll bring them in. Once you bring them in, you can choose what you want to keep and what you don't want to keep. So if maintaining traceability didn't matter to me, I could just turn it off, or I could delete it altogether, like just take it out of the rule set. Okay, so now this is inside of our actual set of rules. So I will come back over here and I will say something like, can you help me create this? And I'm going to upload an image and I'm going to put this AWS. Oh, this was in my screenshots. Let's see which one it was. I guess this one. Okay. This is the MCP server use case, and I'll just do one more thing. Here's a little bit more information. I just want to give it all the context that I have. And then I'm going to ship that off. This is going to feel very much like Lovable, right? So you're in an interface where you're building things based on intent. You've got a chat window, and then you've got a place where the magic happens. This is where your code shows up. This is where your designs show up. And so you can see here what it's doing. It's running some bash or some pwd commands, and now it's running right. And it's kind of laid out here, like based on the diagram description. I see this involves Bedrock Agent Core, Amazon Incognito, S3 API schema storage, ECR, CloudWatch IAM roles. Let me start by creating a well-organized Terraform structure for this solution. Notice it didn't ask me any questions. It didn't like press me to give it any information, and it's certainly not teaching me anything right now. And that's because I didn't want it to. Leave me alone. This is inside of your personal settings. You have the ability to change how you interact with this agent. So I've got it in an expert autonomous mode, meaning I'm going to assume this guy kind of knows what he's doing. He's giving me what he needs to give me. I'm following the rules I'm supposed to follow, and I'm just going to get it done, right? That's this mode. If I move it down here into the collaborative beginner, for example, what this is going to do is say, oh, okay, cool, I'll go to web app. All right, that's pretty nice, pretty nice. AWS, Google, you're going to do this in Azure. What kind of stack do you want to use? Terraform's a really popular choice. Terraform does this. You really should know more about it. Let me teach you some things about Terraform. So that's the way that this ultimately works. But I just want to be clear, like it feels like it was like, I have the answer. I'm going to solve the problem. But that's because I told it to treat me like that. All right. So we'll let this keep going. As it's going, though, I'll kind of pull through it. So anybody that's written Terraform before can judge this with their own eyes and kind of feel like how you feel like the job it's doing, right? One thing that I really talk about, but is apparent in what I'm seeing here is, for example, you see this Cognito pool is called this because there's only one of them. You see that there's a creator tag for Infracodebase. So these are things in my personal rule set. So kind of back to this page where we were here, there's 3 layers of rules. These are my personal rules. So I have a rule here for tagging that says always add a creator tag with Infracodebase in it. You have enterprise rule sets, which we saw. You have workspace rule sets, which we uploaded this AWS well-architected framework to. And then we have my personal rules, which are being respected right now as we're looking at this code. And basically, it's an agentic diffing engine that says, like, hey, the enterprise told me I got a rule I got to follow. Hey, workspace, you got a rule I need to follow? Yeah, sure. Hey, man, whoa, that's different than my rule. My rule is better than your rule. So it kicks that rule out, and it focuses on enforcing the enterprise rules. This is important because what we're really ultimately trying to do is make teams feel comfortable federating this to anybody. Really large teams have very complex setups. Employees all around the globe, different skill sets, different amount of time with your company, different knowledge of your customer, very different levels of experience in the cloud. And so we want none of those things to be the barrier to fast delivery and great infrastructure delivery and great infrastructure code. So anyway, here we see the locals. We see that we have a Cognito user pool client, domain, schema store. Like this thing does not skimp on it. It builds the thing it's supposed to build, and it's sort of non-compromising about that. Which, if you've ever built agents before, particularly ones that are aimed to solve this kind of problem, this is a place where they can get kind of lazy. I don't know if it's because they're like, oh, you have so much context, you can only work with it. So there's a little engineering you have to do around it. But once you get it, you can build something that can actually build robust things kind of end to end in one shot. So this is the main file. Of course, in the providers, we have the AWS provider. Created a README for this. Also, you'll notice like all this is green and like red, and that's because when the agent makes changes, I have the ability, just like in Cursor, if you've ever used Cursor, to like accept or reject file by file or all the changes that the agent is making. And so that way I can kind of make that determination for myself. You can also do things like you can do in VS Code. Like I can just come over here and I can look at whatever my markdown file is and see what's in there. Yeah, we can see we got CloudWatch in this bad boy. Yep, normal stuff. So, all right. So now it's creating a summary document. And then if we look, we have some updates on the diagram side. So this is the diagram that it just created whenever we asked it to create this Terraform code. One really cool thing about agentic architecture is the agent, we gave it eyes. So every turn, it actually physically looks at this. It does an assessment of this as an architect with guiding principles that I myself over the years have curated, building architecture diagrams and creating cloud infrastructure. So embedding that knowledge into the agent, and it's able to use that to make intelligent decisions about how to create something great that reflects what it is that you're trying to actually do. So the other cool thing is that because it's agentic, it's not tied to like a logic engine, that it doesn't matter if I'm using CloudFormation or Bicep or if I'm using Terraform. There's a language there's like a natural language translation of what's getting written in code to the architecture diagram. So there's nothing it can't create. It can also go to the web and get like custom icons from some other place. So like if you want to use a Claude model, there's no Claude icon. You're not limited by some generic icon inside of the product. The other cool thing that we've seen, by the way, so you can see over on the left-hand side, it's done, it validated, it initted, validated, and formatted all the code, all great things as a starting point. Here, it's created this first visual for us. Now, one thing that we can do is that we can start to drag these things around. Notice the score in the top right. This is one thing that is really cool because people that aren't architects or maybe don't have a design eye or kind of have the idea of what it takes to create something that's easy to read, clear to understand, they can use that score to start improving it by moving things up if it goes up. Like this, right? So it's looking at symmetry. You can look at this. It's looking at symmetry. It's looking at straightness of edges. It's looking at crossing. the overlapping of edges, whether or not things are overlapping with containers, whether or not you're using consistent spacing, things that matter when it comes to really seeing, beautiful cloud architecture. Here, for example, I might move this up. And this thing here, I might just move to the middle, so it's kind of not in the way. And then I've got this, right? So I've slowly improved that score over time. Now here, I've got this tool invocations MCP endpoint, right? So what I could do is go into visual edits mode. This works just like Lovable. So I can click on whatever it is that I want to click on. I could say, can you search the web for an MCP icon that we can use in this diagram? I can ship that off, and you can see there's a tag inside of that chat there that says, I was talking to tool invocations. They've asked me something in this context. I'm going to go out and try to solve this problem. So it's going to go and look and say, hey, what icons exist that I can use? And then it's going to validate that to make sure there's not some kind of weird thing in front of it blocking it from getting pulled across the internet. So it's validating the URL, the icon URL. It's doing a check on a second URL. It found one that it likes. It's double checking what's actually in the diagram. It's targeting the node. And then I guess it's not making an update. I don't know. Maybe it did. Let me see if it just didn't refresh it for some reason. Okay, it found something it liked. Usually it's the correct one, but that's fine. I like the hammer better anyway. Yep, so this is what it looks like. Again, you can continue to refine this, move things around, and do whatever you want to do, but ultimately this is the way that this works. Any questions about any of this? Yeah, so there was some feedback from the last session that we had where you couldn't move anything around. It actually wasn't agentic, it was algorithmic. So I took all the things that I built and learned about way back 2019, 2020, building Python scripts to do this using things like ELK and layouts. And I was like, oh, we could just give that to the agent, have it use that, and then it can kind of deterministically lay something out in a way that's more or less optimized. At scale, that really did not work well. And sometimes it was perfect and sometimes it was awful, right? So this was refactored to be fully agentic so that you could have a human agent interaction. And you can also do things like, this won't make sense architecturally, but you can nest things together. You can break things apart. And of course you can undo that as well. I can also do things like click this diagram and say, can you add colored edges to this to indicate information about the flow of data? I wasn't clicked into the box. So that time I clicked on the actual diagram, not a specific node or whatever. I just said, hey, here's the thing. And so now it's going to modify the diagram. And so now notice we have these nice, pretty colored edges that we can work on. So I can see there's user interaction up here, accessing the dashboard. There's an authentication flow with Cognito that we are deploying to this gateway in the runtime. That we have data retrieval from the S3 bucket and from the ECR. Actually, the ECR is a pull container. And then you have monitoring and observability. So it makes it really easy. So this is a pretty simple one, actually. We've done some pretty complicated things with this, and it works relatively well. It's got a self-improvement cycle that it goes through. For if our score was high enough to begin with that it didn't worry too much about doing more work. But if it wasn't happy with the work, it would have gone through and you would have seen it actually making moves like a human would on the screen to try to improve the score and get this to look more like what it wants to look like. And again, you can see here that we have any changes show up as diffs, and then I can accept those diffs or reject those diffs. Another cool thing is that as it does every single action that it actually takes a snapshot, and you can come in and you can look at the diff for everything that's changed from one commit to the last. So that if let's say, oh, I really want to go back to this previous version of something, I can just click this revert button and now I'm back on a previous commit. What questions do you guys have? Anything? And I say guys because there's no ladies in the room, unfortunately. A bunch of dudes. It's a problem. Yeah.
Architecture.
Oh yeah, so this is cool too. So you've seen the single diagram use case, but what's kind of interesting is can you create the same thing for Azure in a new architecture diagram? Don't write the code. I'm happy with the AWS code, but I do want to see an architecture diagram that would do a similar thing inside of Azure. So it is multi-cloud, it's multi-language, and it can build anything it wants as a diagram. So we've seen people use this for threat modeling, C1, C2, C3, C4 architecture, L1, L2, L3, L4 inside of here. Right now, what you're seeing is more of a physical architecture diagram. But the flexibility, because it's agentic driven, there's really no limit to what it's able to create. So in this case, in a second, we're going to see it create an Azure version of this diagram. This is good for learning. So I know we talk a lot about B2B as obviously a thing, but like on the community side, what's really interesting is people do use it for things like this to like learn about the difference between services, how to ship things to different clouds in different ways. So you can see now we have these two different diagrams. I could switch back to AWS or I can come back to Azure, right? But I can actually see here, instead of ECR, we're using container instances. Instead of API gateway, we're using API management. Instead of S3 bucket, we're using Azure storage accounts. We're using an MCP endpoint managed identity, right? This is just the normal stuff, monitor instead of CloudWatch, Intra ID instead of Cognito. Very, very same things, right? Yep. So you can definitely do that. Good question, Vikram. So I want to do something else now. It's like, okay, great. So this AWS architecture is clutch. I really like it. It's meeting all our security requirements. Or is it? Can you actually run tfsec to tell me if it's meeting our security requirements beforehand? So another thing I mentioned earlier, it ships with a certain set of tools. And some of those aren't necessarily documented in there, but like anything that you can think of in the ecosystem that's like really common, has more than like 1,000 stars on GitHub, right? So tfsec, Terraform docs, like all these things are built in so that it can use those on the fly, just like you would if you were in your local environment. Right now it's running Terraform sec, and it found 6 security vulnerabilities. Perfect. So what's cool is you can see it, right? Mutable ECR tags, wildcard IAM permissions, no KMS encryption on S3, no S3 bucket logging, and then no KMS encryption for ECR and CloudWatch logs. So now it's going to go and make those corrections. And as it's doing that, we can actually see what it's changing. So over here, we can look at that diff and say, oh, it was using AES 256. Now it's using the SSE algorithm for AWS KMS. Then down here, so it's adding that additional bucket for the logging that it mentioned that we were lacking. So this is like, think about the confidence, right, that this can give you when you're working with these tools, and think about the accessibility. I'm not a developer. What have I done so far that's coding at all, right? Not a single thing. I could be a security engineer. I could be whoever. Almost down to app developers. Some of the cool things we've seen are people using this for Lovable. They'll create a Lovable app. They'll put it in their GitHub. They'll connect it to the product from GitHub, and then they'll use this to create the infrastructure, and then they'll ship the Lovable app. Talked to a customer the other day, and this is a really cool thing and super flattering for us to hear, but they're highly regulated company, very large, and they were saying, oh, well, we've been in furious conversations with Vercel, but we're not happy with Vercel because we can't have our client data inside of their cloud environment. It's just not acceptable for us. He's like, this is like, you just like your Vercel, but we're your backend, and like we love that, right? Because we have actually abstracted it to the point where it's almost as simple to do as if you were to go into into Vercel and just deploy your app into a kind of a pre-canned thing. But we don't have the limitations of one stack. Okay, so I'll let this finish up, and then I'll go ahead and prep the next thing so you can queue events. Oh, one more thing. Of course, there's tools here, right? So if you have modules, for example, in your Terraform Enterprise Cloud, if you've got modules in your GitLab, your Azure DevOps, and your GitHub, and you want to reuse those because those have been security hardened and used across your company, like think about, you all know, I mean, many of you have probably implemented this at different companies, different part of your career is IDPs, right? Like people build all of this infrastructure modules so that they can accelerate, shift left and accelerate app development to do exactly what we're saying we're solving, which is helping the business move faster towards their use cases. The problem has been all you did is shift left. There's no expertise in that team. So they're like, well, okay, cool, you gave us modules, but how do we stitch them together? We have to read through your docs and still don't know the cloud. So how do we even know what to solve for right here? So you need a massive support organization, and you've shifted effort into a different bucket, maybe, and arguably a better bucket to be shifting it into, but you haven't actually moved the needle on the speed very much. So when you do it this way, what's kind of cool is that it can read the examples and the documentation for your modules and put them together in the way that meets the intent of the user and your security requirements, right? All right, let this finish, and then all security issues have been resolved. Perfect. I'm gonna go ahead and queue it up. I'm gonna do one more thing because I know I don't want to put y'all to sleep and it's getting later, 6:30. One more thing. Can you actually plan and apply this to AWS? I'd love to see this infrastructure in my live environment. So in practice, we don't see a ton of people doing this, right? The reality of large companies is that they've spent a decade stringing together Octopus Deploy and GitHub and custom products that they've made up to be able to just ship an application to a cloud environment. And that's okay. That's normal and standard. But what's interesting is that the agent doesn't have any limitations. So if you think about, it's only limited by the permissions you give it, the scope of permissions inside of AWS or in Azure, right? What does your service principal have permissions to do? So in practice, what you typically see is read-only permissions. We've configured one specifically for this use case to demonstrate the deployment capability of the product. But in practice, read-only is great. And what's great about read-only is that if you go to ChatGPT, or even if you go to like your local IDE, it may not have the instructions out of the box to say, oh, I need to go look at your cloud environment at your VPC. Look at the IP ranges, identify what the right next set of IP ranges are, and use the real thing in the actual infrastructure instead of just throwing in a variable for like IP address space, right? So this actually grounds everything inside of your cloud environment. So here it's running Terraform Apply. Over here is our AWS environment, and we have a tag. This is going to be creator, and it's going to be Infracodebase. I'll search for resources, and you can see none of this was here just a minute ago, right? We just created all of this with the agent, the KMS S3 buckets. The plan shows 34 resources. Oh yeah, it's still going. 34 resources. I don't know. Might take a couple minutes. The reason this is important, and not so much to show you that it can deploy to the cloud, but to highlight the point that what we just created together in an hour right now, this MCP ecosystem on AWS, is not a theoretical thing. It's not a trash thing that you're going to show to somebody that doesn't deploy. It doesn't meet our security requirements. Where's your architecture diagram, bro? I can't ship this to the cloud, right? We did all that together with no expertise, really. I mean, not that we had to sit here and do a lot. So anyway, just interesting stuff. So this is where I get to the kind of the final part, and I'll just say like, so we view this as the future of the way the teams start to work together. I think it's an amplification of the need for skills and not a diminishment of the need for skills, because ultimately we're just abstracting ourselves to a higher level of understanding. We're not spending all of our day typing, copying and pasting Terraform and then making minor modifications and like being in the toil of engineering. We're asking important questions about why don't we have a front door in front of our application? Why isn't it multi-region? It's going to be used in France and in the US and in the UK. And I have a companion that can help me to pressure test those trade-offs and decisions and have discussions. I can share those with my colleagues and they can jump into the same workspace and we can collaborate. They can bring their experience, I can bring my experience, and we can embed the experience of our organization in a way that gives us confidence to ship fast. So anyway, that's it. So it's all of the infrastructure is deployed. We would just need now, if we wanted to actually use this, let me refresh. Oh, like I said, those don't have tags. We would need to refresh this to be able to, push an image into the thing to put the MCP server onto the API gateway. All right, and so don't get billed for this. Please destroy this. I don't have much money. Okay, that's it. Thank you guys very much. Really appreciate you. I don't know how you feel. I would love to talk to you after this. If you've got a minute, I know it's late. You're going to be running out. I'd like to know your thoughts, raw thoughts, feedback on the product experience. The ask is go create an account, play around with it. I would love for you to reach out to me, LinkedIn. We can connect personally. If you know anybody that this could benefit, let us know. We're happy to talk. We're all about helping people be successful with the product and making sure that we're solving real problems for them in the cloud environments. So thank you so much. It means a lot that y'all are here. Appreciate it. Hey, Tarak, I know it's like past midnight in France. It's 12:30 here, bud. How you hanging in?
I loved it.
Love you.
I would have had a lot of questions, but I wanted the audience to talk. So for once, I try to stay quiet, but I followed everything.
Thank you.
Yeah, I think it was very nice. Especially, I would really like to hear the feedback of the person who said that he tried the product in July.
That we were just talking about that. Yeah. So look, we're gonna do some fireside here. Let everybody get home to their families. Tarak, we'll give you a brief tomorrow on any final discussions we had. All right.
Okay. Yes.
All right.
Have a
good
good
night.
one. Bye.
Seriously, guys, thank you it means so much that you're here. Like, we're a small company. We're trying to build a big business, and this is personal for us, and we are so thankful for you. Really.